2011, helicopters flew low over an island, scattering thousands of tiny green pellets across the snowy wilderness. They weren't weapons, but they were deadly. Each pellet was laced with poison for its target. What followed was one of the most unexpected ecological reversals in history. Within 2 years, a cascade of changes would unfold. The target disappeared, the island itself began to heal. This is the true story of the world's largest invasive eradication, and the chain reaction it set in motion. South Georgia Island, a remote crescent of land in the South Atlantic Ocean, lies over 1,300 kilometers east of the Falkland Islands. Before 1775, it was untouched by human hands. Its rugged peaks, glaciers, and steep cliffs were home to millions of seabirds, including storm petrels, prion, and the wandering albatross. The island had no native land mammals. Its birds, evolved over millennia in isolation, nested on the ground, and had no defenses against terrestrial predators. In 1775, British explorer Captain James Cook landed on South Georgia and claimed it for the British Crown. Soon after, sealers and whalers established temporary camps, then permanent whaling stations. With them came stowaways, the black rat, Rattus rattus, and the Norway rat, Rattus norvegicus. These rodents found a paradise of easy food, unguarded bird nests packed with eggs and chicks. By the 20th century, rats were found in nearly all accessible coastal areas. The effect was catastrophic. Petrel and prion populations plummeted. The South Georgia pipit, the island's only songbird, vanished from all rat-infested areas. On smaller islets without rats, birds thrived, an ecological contrast too stark to ignore. Scientific expeditions in the 1980s and 1990s documented the scale of the damage. The guano-enriched soil became sterile. Entire nesting grounds turned silent. In 2004, the South Georgia Heritage Trust, SGHD, initiated plans for an unprecedented operation to remove every rat from South Georgia Island. Covering over 3,500 square kilometers, the island's size and harsh climate made it a logistical nightmare. But SGHD had a strategy: aerial distribution of rodenticide using GPS-guided helicopters. The project would rely on brodifacoum, a potent second-generation anticoagulant. Why brodifacoum was chosen? Brodifacoum was selected due to its high efficacy and persistence, making it suitable for large-scale island eradication efforts. How? Brodifacoum mechanism of action. Brodifacoum disrupts blood clotting by inhibiting vitamin K epoxide reductase, an enzyme essential for synthesizing clotting factors. Rats consuming the bait experience internal hemorrhaging, leading to death after several days. This delayed effect reduces the likelihood of bait avoidance, as rats do not associate the bait with illness. The operation used specially modified helicopters equipped with bait buckets capable of even distribution. The bait, wax blocks containing brodifacoum, designed to withstand cold and moisture. In 2011, Phase 1 began in the northern sector. Timing was critical. Bait had to be dropped in winter when birds had migrated and rats were most vulnerable due to limited food sources. Each helicopter sortie followed a GPS-guided grid to ensure no area was missed. To minimize risk to native wildlife, bait drops were done outside bird breeding seasons. Non-target species were monitored, and studies showed native birds like the pipit and sheathbill rarely consumed the bait. Operations paused between phases to monitor success and allow terrain recovery. In 2013 and 2015, Phases 2 and 3 extended the campaign across the rest of the island. By early 2015, helicopters had delivered over 300 tons of brodifacoum-laced bait across approximately 70% of the island's 3,700 square area. Scientists placed monitoring stations, motion-triggered cameras, and chew sticks to detect rat activity. In 2018, after years of careful surveillance, the announcement came. South Georgia was officially rat-free. It was the largest successful rodent eradication in history. With rats gone, the ecological pressure lifted instantly. Though no cats had been introduced to South Georgia, other islands had shown what happens when primary prey vanish. Predator populations collapse. On Marion and Macquarie Islands, invasive cats starved when rats disappeared. On South Georgia, the vacuum left by rats set the stage for rapid avian recovery. Within months of eradication, South Georgia pipits were recorded nesting in formerly infested areas. By 2017, they were singing in coastal meadows and tussock grasslands long silent. Burrowing petrels and Antarctic prion returned to old nesting burrows. The absence of rats meant chicks could hatch and survive. BirdLife International confirmed breeding population rebounds in multiple sites. Seabirds, especially burrowers, enrich the soil with guano, critical for South Georgia's sparse vegetation. As bird populations grew, plants like the native Acina magellanica spread across coastal plains. Increased vegetation stabilized soils, reduced erosion, and provided new habitat for invertebrates and other birds. British Antarctic Survey, BAS, researchers reported improved nutrient cycling and greater biodiversity by 2020. Field teams conducted repeated surveys using transects and acoustic recorders. Soil samples showed increasing nitrate and phosphorus levels. Remote cameras captured healthy fledglings of species once extirpated from key areas. The rebound was not just anecdotal. It was measurable, peer-reviewed, and dramatic. The success of South Georgia became a blueprint. Conservationists worldwide cited it as proof that large-scale ecological restoration was possible. Similar projects followed on Gough Island, Henderson Island, and Lord Howe Island. The model: identify the keystone invader, apply precise and well-planned eradication, and let the ecosystem respond. South Georgia taught a powerful lesson. Sometimes, the most effective conservation strategy isn't to reintroduce lost species, but to remove the force holding them back. This bottom-up approach, addressing invasive species at the root, led to spontaneous, unassisted comebacks of native fauna and flora. The use of birdificum raised concerns about poisoning non-target species and secondary exposure. However, environmental assessments and long-term monitoring found minimal impacts. Mitigation strategies, such as selective timing and bait formulations, proved crucial. Transparent reporting by the SGHD helped validate the ethical balance of ecological gain versus risk. Today, South Georgia stands as a living laboratory. Its revival continues, guided by ongoing studies from BES and global partners. Lessons from its recovery inform new efforts in the Galapagos, New Zealand, and beyond. The eradication of rats wasn't the end of a story. It was the beginning of a new one. And if you were as shocked and hopeful by this extraordinary story as we were, make sure to like this video, share it widely with your friends, and subscribe for more world-changing revelations about our planet's future.